Hello everyone, welcome to this video about how to use the product rule of exponents. So before we get started, I want you to just take a minute to give yourself a little bit of love and allow yourself to relax. Even if you're having a stressful day, just taking a few seconds to relax can really help and make a big difference, especially in regards to math, because it's a lot easier to learn when you're relaxed. So take a couple deep breaths, give yourself a little bit of love, and then let's make this math easy. Okay, so the product rule of exponents basically says that if you have two powers with the same base and they're being multiplied together, that you can simplify it by adding the exponents together. So in this yellow example, you would get 6 to the 9th because 5 plus 4 equals 9. In the purple example, you'd get 4 to the 5th because 2 plus 3 is 5. And in the blue example, you'd get y to the 17th because 10 plus 7 is 17. The one thing to be aware of is that the bases have to be the same. So if you have a problem like r to the 6th and s to the 8th, you can't simplify that any further because the bases are not the same number. You would just say that it's not simplifiable and you would rewrite it as the problem that they gave you. And the reason why the product rule works is because of the way that exponents work. So if you wrote down 4 squared, that would mean that you have 4 times itself twice. If you have 4 cubed, that means that you have 4 times itself 3 times. And if you multiply those two things together, you basically have a total of 5 4s that are all being multiplied together, which is why it equals 4 to the 5th. So the product rule is basically just a shortcut so that you don't have to write all of this stuff out. You can just use the product rule to simplify the expression without expanding it. And again, this works whether the base is a number like 6, where you've got 5 6s and 4 6s being multiplied together, which give you a total of 9 6s. Or if it's a variable, like if you have y to the 7th and y to the 10th, you'd have 7 y's times another 10 y's, which gives you 17 y's, and that's how that product rule would work. So basically it applies to numbers, it applies to variables, and if you ever have a missing exponent like this, just remember that any number that doesn't have an exponent technically has an exponent of 1. I like to call it the invisible exponent of 1. And the reason why that works is because any number raised to the first power is just itself, which means you can add an exponent of 1 to anything and it won't change the number at all. So if you ever have a missing exponent, you can just know that it's a 1. And then you can say, okay, well, if I have 1x plus 4, or 1x times 4 x's, then that means that I have 5 x's being multiplied together. You can also do this if you have negative exponents. So if you had 3 to the 8th times 3 to the negative 2, you could say that that was 3 to the 6th, because 3 to the 8th is basically 3 times itself 8 times, which takes a long time to write. And 3 to the negative 2 is the reciprocal of 3 times itself twice, so you would put it on the bottom of the fraction, and you'd multiply it by itself twice. And then you could cancel out the 3's that they have in common, which means that you would have 6 3's remaining, and that's why you would get 3 to the 6th, even if you have negative exponents. So that's kind of cool that the product rule applies even when you have negative exponents. And the big thing is just to remember that you have to have the same base, because if you were to expand things that didn't have the same base, you can see why you can't combine them. Because like if you have 4 2's times 5 3's, you can't really simplify that any further because they're not the same thing being multiplied together. Yes, you have 9 numbers being multiplied together, but some of them are 2s and some of them are 3s. So you can't simplify it by adding the exponents together. Same thing if you have different variables like this one. Another thing that can be helpful is the reverse product rule. So basically, it's the idea that you can use this rule in reverse if that happens to be helpful. So for example, if you had x to the 6th, you could split that up into things that are being multiplied together if it's helpful for you. So you could split it up into x cubed times x cubed, or x to the 4th times x squared, or x to the 5th times x, remembering that there's technically an invisible 1 there. Or you could even split it up into 3 things if you wanted to, and do it as x squared times x squared times x squared. This reverse product rule isn't really used very often, but if you ever do need to break up a really big power, like, x to the 6th power, and if you want to break it up into smaller pieces, you can do that by using the product rule in reverse. So to summarize, the product rule of exponents says that if you are multiplying the same bases, then you can add the exponents together to get a simplified expression. You can also use the product rule in reverse if that's helpful. And that's how to use the product rule of exponents. I hope this video was helpful for you. Please comment below to let me know how easy this was for you, and then subscribe. For more help with exponents, check out my Exponents playlist here on YouTube, or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!